look at this. Okay, and so what we're going to have our person, and they're going to start here. So this is going to be the initial location. And I'm going to have the person end, I don't know, over here. At the final location. And so again, what we could do is we could go in and pick out our coordinate system. Okay, so since it's horizontal, we're going to label it as X for our coordinate system. We get to make choices in the coordinate system, and I want to illustrate some things, and so let me go ahead and put that the origin is going to be located here, and that this distance here would be 10 meters. I'll make to the right the positive X and to the left the negative X. And so this is our initial coordinate position. And one of the things we'll do is we'll talk about the notation we're going to use to indicate initial values and final values. And one of the ones that I use here is a fairly standard notation. And so what you get is that if you have a 0 subscript, then that indicates that it's the initial value. So 0 subscript is the initial. And if there is no subscript, then this is the final. Okay. Now you can do different things. You can do I and F for initial and final, and that's fine. But as a general rule, this is the one that I like to use best. They can also do like 1, 2s, and 3s, and that can be really useful. But again, I like the 0 and the no subscript. It's a very common notation. It's the one I've learned, I guess I initially learned, is one I kind of prefer. So even though it's a little difficult if you have intermediate positions to tell anything other than the initial with the 0 subscript, but it's okay. And again, very often what they'll do is when we look at this 0 subscript, they'll read it as not. Okay, so that'll be, X naught is plus 10, or X sub 0 is plus 10, but again, sometimes I'll say not type of things. All right, and so these are the coordinate positions. So these are our scalar values. And then, of course, when we talk about our position vectors, then what you're going to look at is that this is the origin. And the position vector is the shortest directed distance from the origin to the location of interest. And so then what we'll get is that we can draw in our initial position vector. And we can label this as X naught, like so. Okay. Now, I probably should have put down that. Let's go ahead and state that this physically is east and that this is west. And so then when we talk about our initial position vector, it would have a magnitude, which is the length of this vector, which is 10 meters, and it points in a direction, which in this case is east. And so what we could get is that we could write this one down as 10 meters east. But In this coordinate system, since we coded that east is positive, then we could take this east and then write this down as being a plus 10 meters. And so then we have encoded the information into the coordinate system like I talked about at the beginning. Okay, so when my initial position vector is plus 10 meters, then what you get is that the positive sign indicates the direction, and then this quantity here will be our magnitude. Okay, so the 10 meters is the magnitude and the plus sign is our direction. And it corresponds to east physically. Okay, there we go. So there we have it. So we do x naught is, 10 meters east, or coordinate into our particular coordinate system is plus 10 meters. Now the thing you need to recognize is that since every one of us could technically pick a different coordinate system, then we could very likely have different, position vectors. And so we want to make sure that when we give our final answers, then they're in terms of things like, physical quantities like east and west, and not choices we got to make, such as pluses and minuses, things along those lines. And so that'll be an important aspect. And then what we can do is we can come in and go from the origin to our final location and get our final position vector. And so this distance is 5 meters, and the direction physically is west. And then what we can do is in the coordinate system, west was negative, so we can write this west as being, negative 5 meters. And so then what you get is that the sign on our vector quantities indicates the direction, and then of course the absolute value of that is the magnitude. So that's our, length of the vector in these instances. And so then these two quantities are going to be our position vectors. This one here and this one here. Okay, so something like so. And then what you're going to find is that's an important thing to notice is that my coordinate position was plus 10 meters, but then my position vector coded in the coordinate system was also plus 10 meters. And what you get is that there is this kind of one-to-one correspondence between these two quantities. And it's the same here. We've got -5 and -5. So we have that same one-to-one correspondence. And we're always going to have that. And so that's just something that will always turn out to be true, is that, the coordinate position will be the position vector coded into the coordinate system in one dimension. Okay. Once we get into higher dimensions, then this correspondence won't be quite this direct. There's still a correspondence that's available, but it's not between the position vector and the coordinate position type of idea. And it's for this reason that in many of the textbooks, they don't make the distinction between a position vector and a coordinate position. And they don't make the distinction because, well, there's this correspondence between the two. And so then they just don't tend to tell everybody that this is what is going on in this particular instance. Okay.